bivariate normal distribution and the correlation coefficient. So bivariate normal distribution and correlation coefficient. So what is bivariate normal distribution? So say x and y has a bivariate normal distribution, and the parameters are expected value of x is mu1, expected value of y is mu2, and variance of x is equal to sigma 1 square, and variance of y is sigma 2 square. Then when there are two continuous variables like this, you have one more parameter which is called correlation, and it is correlation x, y, and that is called mu. So for bivariate normal distribution, you are dealing with 5 parameters. You have mu1, mu2, sigma 1, sigma 2, as well as rho. So for x and y, the covariance of x and y is going to be expected value of xy minus expected value of x times expected value of y, and variance of x is equal to is covariance of xx, and so it's variance of y is covariance of yy. So that's the definition of the covariance, and we have seen that before. Covariance of xy, expected value of xy, and expected value of expected value of y. Now how do we define rho? And this question is important because we need to define rho. So how do we define rho? Rho is defined as covariance between xy divided by standard deviation of x times standard deviation of y. That can also be covariance of xy divided by under root variance of x times variance of y. This formula remains valid if x and y are discrete random variable or continuous random variable for the rho to be like this. The correlation coefficient rho, because of this formula, correlation coefficient is not covariance. Covariance is described by this formula, which is expected value of the product of x and y minus expected value product of the expected values. The correlation formula will lie between -1 and 1, and that is because of a property called Cauchy-Schwarz inequality, which we will not go into. Now we'll go into one more thing here called conditional normal distribution in the next lecture.